Look up at the night sky, and you're witnessing a spectacle that has inspired humanity for millennia. Every pinpoint of light, a star, a sun in its own right, some orbited by their own worlds. But zoom out, past our solar system, past our local stellar neighborhood, and you begin to see the true majesty of the cosmos. Galaxies. Billions upon billions of them, swirling islands of stars, gas, and dust, each a universe unto itself. They stretch across the fabric of spacetime, forming a cosmic web that seems to extend infinitely in every direction. It's a vision of eternal, unimaginable abundance. Yet, what if I told you that this grand cosmic tapestry, this seemingly endless parade of galaxies, is not forever? What if the very fabric of the universe is playing a cruel trick on us, slowly, inexorably, making these distant islands of light vanish from our sight, one by one, until we are left in a cosmic void? This isn't science fiction. It's a profound, unsettling reality predicted by our best understanding of the universe, a cosmic disappearance act playing out on the grandest possible stage. To understand this impending cosmic solitude, we first need to grasp the fundamental nature of our universe. For centuries, humanity believed the universe was static, an unchanging backdrop against which stars and planets moved. Then, in the early 20th century, Edwin Hubble made a groundbreaking discovery. The universe is expanding. He observed that distant galaxies are moving away from us, and the farther away they are, the faster they recede. This wasn't because galaxies were fleeing from some central point, but because the very space between them was stretching, much like dots on an inflating balloon. Every point on the balloon sees other points moving away from it. This expansion is happening everywhere, all the time. But the story doesn't end there. For a long time, scientists believed that gravity, the attractive force between all matter, would eventually slow down this expansion, perhaps even reverse it, leading to a big crunch. However, in the late 1990s, observations of distant supernovae revealed an even more astonishing truth. The expansion of the universe isn't slowing down, it's accelerating. This revelation introduced one of the greatest mysteries in modern cosmology: dark energy. We don't know what dark energy is, but it acts like an invisible, repulsive force, pushing spacetime apart at an ever-increasing rate. It's this accelerating expansion, driven by dark energy, that holds the key to the vanishing galaxies. Imagine the light from a distant galaxy, traveling across the cosmos towards our telescopes. It's a journey that can take billions of years. While that light is on its way, the space between that galaxy and us continues to expand. The light waves themselves are stretched, much like a rubber band, a phenomenon we call redshift. The more distant a galaxy, the more space expands during the light's journey, and the more its light is redshifted. Initially, this just means visible light shifts towards the red end of the spectrum. But with extreme distances and accelerating expansion, the light can be stretched so much that it shifts completely out of the visible spectrum, into infrared, then microwave, and eventually into undetectable radio waves. It's like turning down the volume on a radio until you can't hear it anymore, not because the radio stopped playing, but because the signal is too weak for your ears to perceive. This redshift is one part of the disappearance act, even if a galaxy is still technically within our observable universe. The region from which light has had time to reach us since the Big Bang, its light might become so stretched that it's practically invisible to our current and even future technologies. We simply wouldn't be able to detect it. These galaxies aren't physically disappearing, but for all intents and purposes, they are becoming undetectable, fading into a cosmic background hum that we can't decipher. However, there's an even more profound and permanent disappearance at play, one that relates to the ultimate speed limit of the universe, the speed of light. While no object with mass can travel through space faster than light, space itself is not bound by this rule. Thanks to dark energy, the space between us and extremely distant galaxies is expanding so rapidly that these galaxies are receding from us at a speed greater than the speed of light. Let's clarify what this means. Imagine a spaceship traveling at near light speed towards a distant star. Even if the spaceship emits light, that light is still traveling at the speed of light relative to the spaceship. But if the space itself between the spaceship and the star is stretching faster than light, then the light emitted by the spaceship might never reach the star. It's perpetually moving through expanding space, never quite making progress towards its destination. This is the concept of a cosmic event horizon, similar in principle to a black hole's event horizon. For us, here on Earth, there is a boundary in space beyond which light emitted today from any galaxy will never, ever reach us. No matter how long we wait, no matter how powerful our telescopes become, the space between us and those galaxies will expand faster than the light can travel across it. They are effectively outside our future light cone. Their light from billions of years ago might still be on its way, eventually reaching us, but any new light emitted from those galaxies will be forever lost to us, perpetually trapped in the rapidly expanding void. Consider the consequences of this accelerating expansion over truly vast timescales. Our current observable universe, a sphere stretching about 46.5 billion light-years in every direction, is teeming with hundreds of billions of galaxies. But this is just a snapshot in time. As the universe continues to expand at an accelerating rate, more and more galaxies will cross that cosmic event horizon. Their light will become irrevocably cut off from us. In the unimaginably distant future, not billions, but perhaps trillions of years from now, the cosmos will look dramatically different to any hypothetical intelligent life that might exist in our corner of the universe. Our own Milky Way galaxy is currently on a collision course with our nearest large galactic neighbor, Andromeda. In about 4.5 billion years, these two spiral galaxies will merge to form a colossal elliptical galaxy, often playfully dubbed Milkomeda. Our local group, which includes Andromeda, the Triangulum Galaxy, and several smaller dwarf galaxies, is gravitationally bound. The gravitational pull within this group is strong enough to overcome the expansion of the universe. So, Milkomeda will remain a coherent entity. But beyond our local group, all other galaxies will have receded so far, so fast, that their light will have been stretched beyond detection or will simply never reach us. From the vantage point of Milkomeda, the night sky would be almost entirely dark, save for the few remaining stars within its own sprawling boundaries. The grand cosmic tapestry we see today, adorned with countless distant galaxies, would be gone. Future astronomers in Milkomeda, looking out into the void, would see nothing but emptiness. There would be no evidence of the billions of galaxies that once filled the universe. No cosmic microwave background radiation, the afterglow of the Big Bang, as even that primordial light would have redshifted into oblivion. This presents a profound challenge to future scientific inquiry. Imagine a civilization arising in Milkomeda billions of years from now. They might look up and reasonably conclude that their galaxy, their island universe, is all there is. They would have no observational evidence of an expanding universe, no direct clues about the Big Bang, and certainly no hint of the vast network of galaxies that populated the early universe. Their cosmology would be fundamentally different, built upon the premise of a static, isolated galactic system. Our ability to observe the cosmic microwave background and the redshift of distant galaxies makes us uniquely privileged observers in cosmic history. We live in a brief window where the evidence of the universe's dynamic past and its vast structure is still visible to us. The implications of this scenario are staggering. It means our current understanding of the universe, its origin, its evolution, its enormous scale is not just a scientific achievement, but a fleeting gift. We are here at a crucial time, able to piece together the grand narrative of the cosmos before the chapters fade from view. It underscores the urgency of our current astronomical endeavors, of building ever more powerful telescopes like the James Webb Space Telescope, which peer back in time to the earliest galaxies, precisely because these distant objects are the first to be lost to the cosmic horizon. The galaxies we see forming in the early universe are already incredibly redshifted, and their light has traveled for billions of years across an expanding universe. For galaxies even further out, or for light emitted from those same galaxies billions of years in our future, the journey becomes impossible. It's important to remember that this disappearance isn't an annihilation. The galaxies themselves will still exist, still be forming stars, still be swirling through space. They simply become forever unknowable to us. It's a cosmic separation, a gradual but irreversible process of isolation driven by the relentless expansion of space. Our galaxy and our immediate galactic neighbors will remain gravitationally bound, a small archipelago in an otherwise endless, dark ocean. This cosmic forecast challenges our anthropocentric biases. We often assume that the laws of physics and the observable universe are eternal and accessible. But the accelerating expansion of space, driven by dark energy, reveals a more dynamic, and in some ways, a more melancholic truth. The universe isn't just expanding, it's becoming emptier, at least from our perspective. The view from Earth today, a sky studded with hundreds of billions of galaxies, is a temporary vista. It's a magnificent, fleeting moment in cosmic history. So are galaxies disappearing? Not literally, not in the sense of being destroyed, but they are, unequivocally, disappearing from our future observable universe. They are receding beyond a cosmic horizon, their light redshifted into oblivion, or simply unable to traverse the ever-expanding gulf of space to reach us. The universe, in its old age, is predicted to become a much darker, lonelier place. Our current age is a unique epoch, a window into the true grandeur and scale of the cosmos, a window that will eventually close, leaving future civilizations to ponder a solitary existence in an otherwise barren sky. This profound realization compels us to ask, what other cosmic secrets are we witnessing just in time, before they too vanish into the accelerating darkness of an ever-expanding universe?